Good morning, students. Good morning to all of you. Today we are going to discuss a new topic, that is determination of B according to the follow the rule Biot Savart law. Okay, we have to find out the magnetic field around the current carrying wire by following the rule of Biot Savart law. Okay, let us see here. We know that a wire having current I, then around the current carrying wire there is a magnetic field. There is a magnetic field. The magnetic field will be denoted by the symbol B, and magnetic field is a vector quantity. We will discuss how it is considered that there is a magnetic field around the current carrying wire. We put a compass near the current carrying wire. The compass needle having some deflection. If you put the compass needle around the current carrying wire, and if you reverse the direction of electric current inside the wire, the deflection of compass needle also be deflected. Reverse the direction of compass needle also be reversed. This phenomena is considered by Oersted, so it is called Oersted experiment. Oersted experiment. Oersted experiment. So, what is the amount of magnetic field around the current carrying wire, or what is the magnitude of the magnetic field around the current carrying wire? We have to find out by following the rule Biot Savart law. Okay, let us see here. Suppose a wire having a current of I ampere. Okay, and we have to find out a magnetic field near the current carrying wire at a distance of r. Okay, at a distance of r at a point P. We have to find out a magnetic field or amount of magnetic field, magnitude of magnetic field at a distance of r from the wire with an angle theta from the element of length dl. Suppose a wire having a length L, and we put an element, we cut an element along the direction of electric current, the element having a direction along the direction of electric current. This element is nothing but it is the smallest or a small amount or a small length of the wire length. Okay, and the element having an angle theta from the distance r, where we have to find out the magnetic field at a point P. Then according to Biot Savart law, the element having some magnetic field, due to this element there is a magnetic field at the point P. This magnetic field is denoted by dB. A small amount of magnetic field will be there for the length dl. The length dl having a current I, and due to this length dl there is a magnetic field of a small amount, that is dB. dB is also a vector quantity. So, according to Biot Savart law, the dB is directly proportional to the current which is flowing inside the dl length, and this dB also directly proportional to the length dl, and this dB also directly proportional to the sine theta, the angle between the dl and the r. Okay, that is sine theta, and this dB is inversely proportional to the square of the distance between the point P and the dl. Okay, and as you combine these four things, we get an expression I dl sine theta upon r square, and as you replace this proportionality sign by equal to sign, we get a constant mu naught upon 4 pi I dl sine theta upon r square. We get a value of magnitude of magnetic field around the current carrying wire. This mu naught by 4 pi is nothing but this mu naught upon 4 pi is nothing but it is a constant, that is 10 to the power minus 7 Newton per ampere square. This is the value of mu naught by 4 pi is constant. Okay, here mu naught is permeability of the vacuum. This one the permeability. Okay, permeability of vacuum or free space. Permeability of vacuum. And 4 you know constant, pi is the radian. Okay, and where is the direction of the dB? How we can conclude the direction of dB? Let us see here. For the direction of dB, we multiply by how much? Ideal sine theta divided by r square. For the direction of dB, we multiply by here a r cap, that is the unit vector of r, and we know that the r cap you can write the vector r divided by the magnitude of r. The r cap or the unit vector of r can be written in the form of the vector r, and the divided by r the direction, this one the with direction, and this one only the magnitude of r, and if you divide you will get a unit vector r. So we can write from here that mu naught by 4 pi I dl sine theta divided by r square. Here you can write r vector divided by r magnitude, and if you multiply you get a value I dl sine theta r and r cube. This will multiply and becomes r cube, and we know that mu naught by 4 pi I dl, this one I and dl cross r. From here to here you can write dl cross r, dl cross r, because dl is also a vector quantity. We consider that dl, direction of dl is along the direction of electric current. So this will becomes dl cross r divided by r cube, and this is a vector form of magnitude of magnetic field present around the current carrying wire. So where the direction of dB, the direction of dB, that is the direction of dB along the perpendicular to dl as well as the direction of dB is perpendicular to the r vector, because we know that the direction of cross product is always perpendicular. This will give the direction of dB. Okay, direction of dB. Okay, direction of dB is perpendicular to dl as well as the direction of dB is direct perpendicular to r, and this one the scalar form of magnitude of magnetic field around the current carrying wire at a point P, the distance r having angle theta, and this one the vector form of magnitude of, this one the vector form of dB, that is magnetic field around the current carrying wire. I think you are able to follow me. Thank you very much.